Part 3. Agentic patterns, MCP versus A2A, guardrails, observability, memory tiering, and approval gates that block EHR, patient email, and build codes. Part 1 covered architecture, ICD/CPTRAG and eval. Part 2 covered each agent. Multi-agent systems fail in ops and compliance, not laptop demos. Synthetic data only. MCP standardizes tool and data access. Database ops, ICD/CPT, lookup, EMR approval queue. Not raw FHIR vendor AP is. A 2A handles bounded workflow between services. Validation, FHIR build. Approval, FHIR client. The model does not choose between search and create. Rule of thumb, MCP asks what tools and data can I access safely. A 2A asks which agent handles this bounded workflow, CFO. LangGraph gives you bounded React inside one agent. The orchestrator is your authenticated user-facing workflow. Anti-patterns to avoid. Fake MCP without list tools. Notification email MCP without a real listener. And LLM orchestrating FHIR step by step. Guardrails and coding compliance. Layers before and during agent calls. Input guards, injection, XSS, path traversal, oversized payloads, scrub PHI from coding queries. Business guards, state transitions, RBAC, ownership, session validity, approval before EHR or notify. Circuit breakers with per-agent failure isolation, timeouts, seconds for transcription, tens of seconds for notes, rate guards with Valkey-backed per-user quotas. Coding compliance is a deterministic pass-to. Format rules, CCI/NCCI graph, mutual exclusion. Model suggests, graph validates, humans approve. Validate early, fail clearly, never silently degrade. Observability. One clinical session across 6 services needs correlation IDs and traces. The contract. Request ID per HTTP call. Correlation ID per journey. Session ID in Postgres and Valkey. W3C traceparent for open telemetry. Same correlation ID in eval runs. Target. OTLP to a vendor-neutral collector. Prometheus on every agent. On a status today. Transcription has full OTel and Prometheus as the reference implementation. Summarizer has Prometheus. Orchestrator has traceability, but middleware is not wired. Notes has correlation middleware, but no Prometheus yet. Notification uses JSON metrics, not Prometheus format. End-to-end waterfalls are the target, not production ready. Never put patient ID, session ID, or transcript in Prometheus labels. Memory tiers and approval gates. 3 tiers, not one database for everything. Postgres is durable truth, sessions, final results, audit, agent private schemas. Shared_KM holds durable knowledge. Templates, ICD/CPT with version. Promoted ingestion output. Neo4j holds CCI/N/CCI/LCD graphs. Agents read. Writes happen via promotion or ingestion only. Valkey is hot and ephemeral. Session state, RAG cache, rate limits, working memory. Canonical keys follow the pattern. MAI, tenant, environment, class, scope, ID. Bounded TTLs always. Never put the full code corpus in Valkey. Never put PHI in key names. Approval gates. Notes are not final at model JSON. Codes are not billable at retrieval score. Blocking flags on EHR write and patient delivery. EMR sits at the FHIR boundary, pending approval before vendor send. Notification fires post summary after delivery approval. Backend flags beat UI only hiding. This prevents race conditions and auto-billing from model output. Eval. Faithfulness in staging, humans gate production. Themes from Part 3. MCP for tools, not FHIRAP is. A 2A for bounded workflows. Layered guards plus deterministic coding compliance. OTL and Prometheus, honest about gaps. Valkey hot, Postgres and shared _KM durable. Approval blocks EHR, delivery and final codes. Eval as an ops pattern. Up next in part 4. Up next, shared platform database, ICD/CPT ingestion, phased migration, and object storage. Thanks for watching.